We're going to find the GCF of the following in each part. Remember, the GCF is the largest factor that divides evenly into the given terms. In part A, we have 63, 81, and 90. Now, you may have been told way back when that you can, for instance, write out the factors of each number. For instance, for 63, you'd have, I'll just write them out. You have 1 and 3 and 9. Oh, and 7 and 9, I should say. And 21 and 63. And do the same thing for 81 and do the same thing for 90. Well, what will happen is on this list, you would look for the largest number in each group. And you would notice in this case that it would be 9. This is hard to do in my head. I'm so sorry. What is that, 18? I'm going to go with 18. 45, 90. So for the numbers, you might be able to do it in your head. You won't have to do this list, which is totally fine. But 9, what that means is that 9 is the largest number that divides evenly into 63, 81, and 90. Now in part B, we have 50x squared y squared and 20xy. You want to do parts separately, meaning let's look at just the coefficients 50 and 20. The largest number that goes into 50 and 20 would be 10. X squared and x, the largest factor of x that goes into both x squared and x would just be x. So notice you take the smaller exponent. And for y squared and y, again, take the smaller exponent, just y. So the GCF of part B is 10xy. And then in part C, again, look at the coefficients, 9, 18, and 9. You would say 9. Look at the x's, x squared, x to the fourth, x cubed. Take, again, the smallest exponent, x squared. And for the y's, y cubed, and y squared, y squared. The reason you have to take the smaller exponent is because if you took a larger one, then that larger one would not divide into a smaller one. So that's finding the GCF.